Okay, we're back to factoring, but this time, the leading coefficient is not going to be a 1. So remember, we have two methods. In the easier method, this coefficient here was a 1. Okay, and there's a separate video that speaks to how to factor those. When you get to a problem where the leading coefficient is not a 1, which is the case here, the leading coefficient is a 2, we have to modify our approach. The first step in that approach is similar to the other method, a little bit different. In this case, we're going to find two numbers that multiply to the outsides. The outsides being the 2 and the 3. 2 times 3 is 6, so we need two numbers that multiply to 6. And for the add part, it's still going to be the middle term. We're still adding to 5. Okay? So we still have to find two numbers that multiply to something and add to something, but in this case, when the leading coefficient is not a 1, what you multiply to is the product of the outside terms, 2 times 3. So now we need two numbers that multiply to 6 and add to 5. The two numbers that multiply to 6 and add to 5 are 3 and 2. 3 times 2 is 6. 3 plus 2 is 5. So we found our two numbers. Now what we need to do is we need to rewrite the middle term using those two numbers. I haven't changed the problem. Okay, 2x and 3x is 5x. We're still 2x squared plus 5x plus 3. Okay, we just opened up the middle term, which is 5x, based on the two numbers, the 2 and the 3 that we came up with. We split the problem in half. Okay, and now what we need to do is treat it as two different problems. We got to look at the left side and the right side separately. And what we need to do is find the greatest common factor on each side and factor out. So let's talk about what that means. We have 2x squared plus 2x. First we look at the integer. We have 2 and a 2. We can pull out a 2. Let's look at the variable. We have an x squared and an x. The most we can pull out is x, because there's only one here. You can't take out 2. You can only take out 1. We're talking factors now. What's left? Well, let's look at the first term. We took out 2x. We have a 2x squared. So there's an x term that never came out. And on this term, we had 2x. We took out an entire 2x. And when that happens, you need a placeholder of 1. Now the way we could check to see that we did this step properly is, let's do the reverse. We just said that this is pulling out the greatest common factor on this left side, but let me go ahead and undo it. We put it back to the way it was. Well, 2x times x is 2x squared, and 2x times 1 is 2x. And 2x squared plus 2x, that's exactly what we started with. So we did this correctly. You can always check to see that when you pulled out your greatest common factor, that you did in fact do it correctly by checking that if you put it back, it takes you back to the original. On the right side, we have a 3x and a 3. So 3 and 3, I can pull out a 3. And that's all I can pull out. There's an x here, but there's no x term here, so there's no common factor. What that leaves me with is x plus 1. And if I went ahead and checked it, I'd have 3x plus 3. And that is exactly what we started with. At this point, what you want to do is check to see that these two parentheses are identical. They will always be identical if you've done the problem right. If you get to this point and these two parentheses are not identical, you made a mistake. Probably either in the two numbers you came up with here or in pulling out these factors. Once you have them set up and you have matching parentheses, the answer is there. One of the factors will be x plus 1 in this example, which is the parentheses that match. You just pull it down once, not twice, just once. And the other factor will be the two coefficients here, the 2x and the 3. And that's your answer. Okay? If I FOILed this, I would get back to this. Let's do another one. We'll call this one number 1. Let's go ahead and do a number 2. Let's make number 2 be 3n squared plus 7n plus 4. So remember the steps. The first step, two numbers in this case that are going to multiply to 12, add to 7. Okay, multiply to 12 and add to 7. Well, what are two numbers that multiply to 12 and add to 7? 4 and 3. 4 times 3 is 12, 4 plus 3 is 7. I go ahead, the middle term, instead of 7n, I'm going to use these two numbers. I'm going to split the problem. What can I take out? Well, I have a 3 and a 4. They do not go into each other. Cannot take anything out there. I have an n squared and an n. I can take out an n. It leaves me with a 3n plus 4. Let me check. N times 3n is 3n squared. Yep. N times 4 is 4n. We're good there. 3 and 4, I can't take anything out. I have an n, and I don't have an n here. There's nothing I can take out, so I use a placeholder of 1. Okay, and notice the parentheses match. So my answer is 3n plus 4, and then n plus 1. Okay? Now, if I asked you to solve, meaning, take the same problem. If I had said 3n squared plus 7n plus 4, and I said equals 0, and I said solve it, you're going to go ahead and factor it, just like you did up here. And then you're going to take one additional step. Just like before, you're going to take your two factors, and you're going to set them individually equal to 0. So we said 3n plus 4 equals 0, and we said n plus 1 equal to 0. When I solve for n here, I get 3n equals negative 4, divide by 3, and I get n equals negative 4 over 3. On this one, when I said n plus 1 into 0, I get n equals negative 1. So on this problem, if it was factor, if it was simply factor, there's your answer, right here. If it was solve, don't stop here. Set each of these parentheses individually equal to 0, solve for n, and circle your two values of that. Good luck.